Good morning, everyone. I'm Uma Maheshwari, AP Triple Department, RMD Engineering College. In this video, I'm going to discuss about the subject High Voltage Engineering E8701. And in that, we are going to discuss about the Unit 2 Dielectric Breakdown. In this video, we are going to discuss about the topic dielectric material and about the Townsend's theory of first ionization process. Now, first, we'll discuss about what is dielectric material. So, the dielectric material will have a high specific resistance, high temperature coefficient of resistance, and a large insulation resistance. In case of dielectric material, the temperature coefficient of resistance is negative, and it is defined for a non-metallic material. Now, what are the different properties of a dielectric material? So, the energy gap in a dielectric material is larger, and the temperature coefficient is negative. The electric material have high resistivity, and attraction between the electrons and the paranucleus is strong. So the electrical conductivity of this material is very low, and they carry no free electrons to travel. So what are the various insulating materials? The insulating materials are air, nitrogen, carbon dioxide, freon, and then sulfur hexafluoride. These are the different insulating material. So gas is used as an insulator, and it is used in power transmission line and power apparatus like generators and motors. Now, before going to the topic, we must have a basic knowledge of what is breakdown voltage. So the maximum voltage applied to the insulation at the moment of breakdown is known as breakdown voltage. So the different properties of dielectric medium: it has large breakdown strength, and it is provide more flexible and reliable, and it is chemically stable, and the R quenching properties are high in case of SF6 gases. So what is the difference between dielectrics and insulator? So material which is able to develop an electric field with minimum loss of energy is known as dielectric material, whereas here insulators have low conductivity, and it does not allow the flow of current or flow of electrons. So here in case of dielectric material, it is weakly bond compared to insular, whereas it is covalently bond. So the dielectric material store charges. It does not allow the flow of charges, insulators. And these dielectric materials are used in applications like power cables and capacitors, whereas insulators are used in high voltage systems and conducting wires. So what are the different application of dielectric properties? It is used for capacitance for storing charges, and is used in transformer as an insulator and as a cooling agent. So the different dielectric mediums are air, nitrogen, carbon dioxide, freon, sulfur hexafluoride. The dielectric discharges is taking place in two types: non-sustaining discharges and self-sustaining type. And the mechanism of breakdown is discussed under two different theories. First one is Townsend's theory, and second one is streamer theory. So in this class, we'll go into a detailed discussion of Townsend's theory. So in Townsend's theory, or Townsend's first ionization process, here you can see a cathode material and an anode material. And the cathode is connected to the negative of the supply. Anode is connected to the positive of the supply through a current limiting resistor. The adjustable high voltage source is given as input, and the distance between the plate is represented as D. So the process of emitting an electron from a gas molecule with simultaneous production of positive ion is called as ionization. Now, in order to understand the Townsend's theory, here an electrical field is applied between the anode and cathode, and the electrons from the cathode collide with the neutral molecule and produces a positive ion and a new electron. This additional electrons again collide with other neutral molecule, and this repeats, and the ionization collision takes place. So in the Townsend's first ionization coefficient is represented by the symbol alpha. So here, in Townsend's first ionization coefficient, the average number of ionization collisions made by an electron per centimeter travel in the direction of field is called Townsend's first ionization coefficient. Here the alpha depends on E and P and pressure P. Okay, alpha depends on E divided by P and pressure P. So in this discussion, N naught represents N naught. N naught represents the number of electrons leaving the cathode. Okay. And N represents the number of electrons at a distance x from the cathode. Number of electrons at a distance x from the cathode. So here the Dn is proportional to alpha into n dx electrons. So here in this Dn is equal to alpha nx dx. Separating the variable in this equation we get dn by n is equal to alpha into dx. Integrating the equation on both the sides. So it is by when we integrate this equation, integration of dn by n and integration of alpha dx. We get ln n is equal to alpha x plus a constant. Okay. Now, in order to find the n value at x is equal to 0, what is the n value? So, what is this x after a distance x from the cathode material? When this x is equal to 0, whatever electrons at the cathode is same, which means that the number of electrons at the cathode n is same as n naught. So, you can obtain as n is same as n naught, where n naught represents number of electrons leaving the cathode and n represents number of electrons at a distance x. When x is equal to x, n is same as n naught. Therefore, ln of wherever n is there, replace it as n naught and substitute x as 0. So this term vanishes equal to a. Now we have the value of a. Substitute this a value in the expression. So ln n is equal to alpha x plus ln of n naught. Now here bring this ln term to the other side, left hand side. So it is ln n minus ln of n naught. Minus can be represented as ln of n by n naught is equal to alpha x. Now at a distance x is equal to d, we get n as n naught e power of alpha d. So this can be represented now in this expression. When I take the integration part, I get the expression as n by n naught is equal to e power of alpha x. This thing I can write as n is equal to n naught e power of alpha x. So n now I want the relationship between the electrons and the current. Number of electrons is nothing but the current flow. So wherever n is there, I am replacing it as I, and n naught is replaced as I naught. So here the expression as I is equal to I naught e power of alpha d. Whereas I naught represents the initial current at the anode. So this is about the explanation for the Townsend's first ionization process. And in the graph of first ionization process, we can see that with the increase in voltage, the current increases in a linear manner. Thank you, everyone.